A proton travels at 2 times 10 to the 7 meters per second in a plane perpendicular to a uniform 10 millitesla magnetic field directed out of the page. So in part A, to draw a diagram of the path the proton follows. So I'll just do a bunch of dots representing the magnetic field pointing out of the page. And we know that at any given point, it moves in a circular path. And the direction of the circular path, well, if you just point your fingers in the direction of motion, so let's say it's moving upward over here, and curling toward the magnetic field, which is out of the page, your thumb points inward. So you can see that it would start the particle moving in a path that looks kind of like this. I'm going to put several arrows on there to indicate that it's going clockwise. In part B, quantitatively describe the path of the proton. So quantitatively means we're going to have to include some numbers. So the easiest thing to do is just calculate the radius of this circle, which is the mv over qb. The mass of a proton is 1.67 times 10 to the negative 27 kilograms times the velocity of 2 times 10 to the 7 divided by the charge of a proton, that's 1.6 times 10 to the negative 19 times the magnetic field, which was 10 millitesla, or 10 times 10 to the negative 3. And that gives you a radius of 20.875 meters. So just to describe the path of the proton, we could say that it moves in a clockwise circle, a radius 20.9 meters. Part C, qualitatively describe two differences in the path if the proton were replaced by an electron. Well, one of the obvious differences is because we're now dealing with a negative charge, the forces are going to be in the opposite direction, which means that it is going to go in a counterclockwise circle. The other difference is based on this equation. Since R is equal to mv over qb, well, an electron has the same magnitude of charge as a proton, so the q is not going to change, and the v and the b aren't going to change, but it's got a much smaller mass. So the much smaller mass, because that is significantly reduced, means the radius is going to be significantly reduced since those are directly related. So the two differences, one of the differences was the counterclockwise circle, and the other difference is that it is in a smaller radius. And for part D, determine the amount of work done on the proton by the magnetic field. Since it's moving in circular motion, and the work done in circular motion, or also the work done by magnetic field, is always 0 joules, since the force is always perpendicular to the displacement. So force is perpendicular to the displacement,